Right, so the topology is ready as we saw in the previous session before the break. And now we need to configure VRRP as it is said here. I have said that you need to use the group ID for 2000 is 100. IP address is this and should be master on. Actually, in VRRP, master and backup is the relationship, not active standby. Active standby is HSRP. Now, how to achieve this? Let me go to switch 1. Interface, first of all, I want to ping and verify. Ping the other switch address 10.1.100.3. It is pinging. Switch 1 is pinging. Switch 2's SVI 2000. Do you agree?
Yes.
Likewise, 2001 SVI is also pingable. Now, it is time for us to start VRRP. I go under interface VLAN 2000. And the command is VRRP. And then the group ID is 100. IP address is, no need to type ADD. You just type IP and then space 10.1.100.1. 100.1.
Okay.
And I want this 200 to be active on this device. VRRP preemption is already enabled, so you don't need to enable that. I'm simply giving the high priority. What is the default priority in Cisco?
100.
Yeah, I'm going to say 102. Just 2 number more than the other switch for this VLAN 2000. You got it?
Yes.
Let us verify show VRRP. You can see here the configured priority is 102 and the master is local. This is the floating IP address. Now let us move. Okay, let us create another one. Interface VLAN 2001. VRRP group ID is 101. IP is 10.1.101.1. And don't do any priority configuration here because we want the other switch to be the master for this VLAN. Yeah. Right now it may say master, but as soon as I configure the other switch with a high priority, it will take master there. Switch 102 will become master. So let us verify now, show VRRP. As of now, we will see both as master because the other one is not ready. And I have not changed the priority, it is default, and you see preemption is enabled. So you no need to enable preemption if you're configuring VRRP. It is enabled. Now going to switch 2. Interface VLAN 2000. What? I did not say preemption. Okay. Interface VLAN 2000, and I need to say same IP address. IP VRRP. No IP. VRRP. Group ID 100. IP address. Same address because it's a floating address, no? And don't configure any priority here. And go to another one, interface VLAN 2001, VRRP 101, IP is 10.1.101.1. For this, you set priority. See, right now it is backup. When I say priority, VRRP 101 priority, look at this. Even though I did not set priority, it has become master. You know why? Because the
No.
IP address of this switch is bigger. But
Mm.
don't rely on that. You should not rely on
Right.
IPv4 tiebreaker. So I should set the priority 102. Okay. Now let us go and verify on the other switch. First, let me go to other switch and verify. Show VRRP. I can see that 101 is a backup because the local
Mhm.
priority is 100, where the other one's priority is 101. Sorry, 102.
Two. Mhm.
But for VLAN 2000, the local is 200 and, sorry, 102. So this is the master. Yeah. Okay.
Right.
Let's go to switch 102. Here, if you see the opposite, you will see. Here it says for 2001, this is master because the priority is higher. Whereas
Mhm.
for 2000, this is not master, it is a backup because of the priority lower. The other switch with this IP address, who is
Yes.
this guy? It is switch 101. You see, 101 has got 100.2. Okay, now we have
Right.
achieved, but what if this end goes down? And if the line protocol don't go down here, it won't go down in simulated environment as well as in the real world. If somewhere on the remote when the wire get cut, you will not know. The line protocol will not go. For that, we need to
Right.
trace one of the remote IP address, and if the trace fails, we need to make the master as a standby and backup as a master. All right. So in VRRP, if you want to trace
Mhm.
a remote IP, you need to depend on IPSLA. So we are going to now take some assumption like how frequently you will send the ICMP echo packets, and what is the timeout value, what is the wait time to decide the IPSLA is down. All those stuff we will first
Mhm.
discuss and then we will proceed. So this is what the condition is. We need to write an IPSLA to ping R11 and R12's loopback. Let me first of all check whether I'm able to ping. Ping
Mhm.
10.1.255.11. Because I'm running OSPF, I'll have reachability. 10.1.255.12. Right. And let me also ping from other switch because we need to do this in both switches. Ping 10.1.255.11. Ping 10.1.255.12. Okay. We are pinging, which means it's ready for us to do this IPSLA that we discuss here. Probe should be every 5 seconds, and the
Mhm.
threshold or the timeout should be 400 millisecond, and the track should be considered down after 15 seconds, which means 5 seconds of probe plus another 10 more seconds. Let's see how to configure this.
Right.
IPSLA and then an ID, the track, the SLA ID, not track ID, SLA ID. What do you want to use? It was said that you should use, you see, ICMP echo. Using ICMP echo. You can also use TCP connection. Security guys will
Mhm.
use TCP connection or UDP echo and all. Now I want to use ICMP echo because that's what we discussed. ICMP echo, to which address you are
Mhm.
sending? I'm
Mhm.
going to send to 10.1.255.11. 255.11. And how frequently means probe, how often you are going to probe? Every 5 seconds. And then the threshold. The threshold is 400 millisecond. The reason why I'm setting threshold is, please pay attention. I can say timeout 400 millisecond, but it won't accept because the threshold by default is 5000. If you want to set 500 as a timeout, you need to change the threshold. You got it? So I'm configuring threshold to be 400 so that the timeout can also be set as 400.
Okay.
Before, when I was setting timeout, it was showing error.
Nice.
Now it accepted because I changed the threshold from the default 5000 to 400. Okay, now what next? Next is
400.
okay, fine, blah blah blah. Okay, now let us do the other one, other ping. You need to also ping router 12. So I'll say IPSLA2, ICMP echo to the destination 10.1.255.12. Frequency is 5. Threshold is 400 millisecond. Timeout is 400 millisecond. And what else? Okay. Next is in the track command. We'll say another 10 seconds later.
That's it.
Okay. Now what is next is the track. Track. Give any number. I'm going to say track 1. This is not SLA number 1. This is track 1. And then IPSLA 1. And then delay. Delay is 15 seconds, isn't it? Already the frequency is 5, so I'm going to say delay is 10. Delay down is 10. After waiting 10 seconds, if the reply is not coming, consider as down. Yeah, enter. Likewise, I need to have another track. Track 2, IPSLA 2. Delay down 10. And what else? Exit. So we have tracks, 2 tracks. Now let us quickly discuss few more assumptions, and then scenarios, and then we'll come back and come. So Boolean OR can be used if you want to have 2 tracks as one single track. If either this or that. You got it? Either this or that. So I'm going to say track.
Yes.
Now one more thing, I forgot to do. In the IP SLA, when we created, we did not say from when it need to be active. IP SLA 1, from when it needs to be active. All right, so for that, IP SLA 1. Why it goes straight to echo? It goes straight to echo. I should have configured earlier. It immediately comes out.
No, no one.
IPSLA. SLA. So it's not here to schedule. It is IPSLA
Go straight to
schedule.
echo.
Schedule. And what is the SLA number? 1.
SCH.
Now, what is the start time now? And what is the lifetime? Forever. Right? So it is started now. Likewise, IPSLA schedule
Right.
to start time now, lifetime
No, 2.
ever.
Okay.
Now, what is next is we now have 2 tracks and 2 SLAs, and I would like to make it as one. How to do that? Track. I'm going to give a number. Earlier we have used 1 and 2, right? I'm going to use track 10. Track 10 list Boolean. And or. What do you want? Or I want. Either track 1 or track 2. Track Boolean. Object. Track number 1. Object. Track number 2. That's it. So now, how many tracks you have? You have only one. Yeah. Yes. Let me show you what we have.
It's track 10. Right. It's track 10.
Section IPSLA.
But we have 2 in there.
So these are the things we have done. What is missing here is the track 10 that we created is missing. I'll show you that one. Let me paste this to the note. Oh, no. We also have another track, so I'll say track. This is the one missing there when I was showing you there. Okay, so this is the same thing which I need to paste it on the other switch. So I'm not going to type again on the other switch. I'll go straight to switch 2 and put it there. Are you convinced? We need to track from here to these 2 loopbacks, isn't it? I'm not able to hear you. Okay, so I have pasted. Now only one missing piece is I need to call this track number 10 under VRRP in both the device. That's all. Let me do that. Are you ready? Interface VLAN 2000. VRRP 101 track. VRRP 101 track 10. If the track fails, I want to decrement by 5. If I decrement 5 from 102, it will become 97. Automatically, the other switch, which is right now backup with 100, will become master. Do you agree? Fine. Now, should I do this on switch 2 VLAN 200? No.
Yes.
In switch 2, who is active? 2001 is active, isn't it? And that only I should do. Interface here, VLAN 2001 only I should say. VRRP 101 track 10 decrement 5. Let us go and verify this. Show VRRP. You see here 101, you have a track object. If it is failing, if the state goes down, it will decrement 5 from where? From this. Yeah. If it decrements 5, it will become 97. The other switch will be 100. So other switch will become master. Correct? So I'll go now to switch 1.
Master. Yes.
And interface VLAN 2000. VRRP 100. Track 10. Same 10 because we have used Boolean down. 10. Decrement 5. So here we are doing under VLAN 2000. There we are doing under VLAN 2001 because this is what master. Now we have finished. So, show VLAN, sorry, VRRP.
Yes.
You can see for VLAN 2000, the track has been used. For VLAN 2001, we don't track here. Okay. Now, how do we test it? Are you ready for the testing? Tell me which one is master for VLAN 2000?
Yes.
Okay. Let me now go to this two interface of router 11.
It is switch 1.
I'll go and shut down this link and this link. The track will fail, no? I will not be able to ping this or this, isn't it? As a result, the master from here will be falling to this one. Do you agree?
Yes, that's correct.
Let's test it. Right now, if I go to switch 1 and show you the SLA, show IP SLA statistics, you can see now SLA 1 and SLA 2 is okay. It is okay. It's working. It's active. But when I go to router 11, interface Ethernet shut down, router 12, interface Ethernet 0/1 shut down. Now if you go to switch 101, SLA will fail. I'm waiting. See, timeout. You see? SLA. Okay, sorry, it's coming. Again, it has come. I've shut down. Let's see. Okay. But why the return code is still okay?
Try now.
Let us check the VRRP. Show VRRP. No, this is still a master. So there is some way that this is pinging. What may be the way? I want to shut down this link, okay? There are chances that somehow there are chances that it will go like this and ping like this. Oh, is that the one which is going on? Let me first try shutting down this link, okay? Shut down that link.
Mm.
Trace
I would do a
10
trace route
dot
from switch 1. Let's
1
see where
dot
it's going.
255 dot 11. It is going to 100.3, which is the down switch. Okay, it is taking this U-turn here, like this. And then it goes to 101.3. 101.3 is same, it is getting routed here. And then it goes to
Mm-hmm.
100.3. Again, it is going, why it is, okay. Just two packet. Okay, let's see the next hop. It has gone to 11.11 from here. Where is one not? Oh, look at this one. It goes like this, you see? This link is still up. This link is still up. It takes like this a U-turn. So I have
Mm-hmm.
to do something to stop this guy going like
Yeah.
this.
Find a way.
What can I do to test? This is
Mm-hmm.
because it is having layer 2. It is pinging. If I shut down this port also, then it will not. Let's do it.
Yeah.
Interface Ethernet 01 shutdown. Okay.
Shouldn't.
Now
Yes. Go
definitely it
ahead.
is going to work. Yes, timeout I can see on the top. Okay, it is gone. Okay. Now how is it pinging? Let me try pinging. 10.1.255.11. Somehow it is going.
Yes.
What path it is taking? See, in the real world, it is not possible because this is in the real world. It is LAN network. It is private network. This is all public. It won't take a U-turn
It's
like this
taking a
and go. But in
bottom
here,
link.
we have alternate networks. See, again, it is going to the down switch.
Right.
Okay, it will take 102 link and then it will take this uplink.
It's going to take that 102 link. Yep.
Going to take uplink. Let me shut down that port
So
also.
you go to the 102
Oh no, for
and go to
testing
that
this
Gen 1112.
interface
Yes.
Ethernet 02
Right.
shut down. Okay, now not pinging. Okay, now we are expecting switch 2 to be the master. Let's go
Should
to the
not
switch
go
2 and
now.
check.
Sure.
Switch 2 show VRRP. Okay, now it is going. Switch 2 should say still back. Okay, give some time.
Mm-hmm.
I'm expecting this to be the master. Okay, track IPSLA 1 is down. Okay,
Right.
we have Boolean, no? 1 or 2 we have said. Uh-oh. What? This can still ping this 10.1.255.12.
And you're trying to go to,
So
but
we'll
guess
do
what?
one thing. Instead of shutting down all these ports, let us shut down these 2 ports. Ping.
No,
Okay, so
12,
let me
yes,
go
12.
down to router 11 and unshut. And I'll go to router 11 and unshut the other
Yes.
interface as well. Interface Ethernet 0, 0, no shut. Interface Ethernet 0, 1, no shut. Did I shut down any interface on R12? Okay, now, as we planned,
No.
interface range G00-2. I'm going to shut down this interface. Shut down. Now show VRRP. It has become master backup now. Show VRRP. Sorry, it is master for both. No. Now only track is see. Track is going on. Boolean is also down. And now I'm expecting a decrement of prior. Oh, no. I know where I made mistake. Did I?
Oh, there it is. It's there. It's there. Up.
Let
Scroll
me
up.
try. It is still master. Even though this is down, how can this be a master?
Yeah, but if you go up here,
Let me go to switch 2 and check what is your
because
status. Show
I think you
VRRP.
shut down all of that port up top. All the ports on the
Here
top
this
switch
is
have been shut
master.
down.
This is also master. What about switch? What did I shut down?
Go to switch
Oh,
101.
2 means it
101 and look
includes
at the
1 also.
interfaces.
Sorry.
When you said interface
So
range, you
that's a
said
mistake. That is
zero
why.
zero
So
to 2,
HSRP will
but this
become
is 01.
discontinuous.
Yes, yes.
Okay. Let it come back. Okay, when it comes back, I'm expecting this to be the master for 2000 and that to be the master for 2001. Give some seconds. This should go back up. Yeah, this should go back up.
Yes. It's coming.
Yeah. So 101 is back up here and 100 is master. 100 is master. So this is nice. Now, this is the original condition. We need to test the track. In here, show VRRP 100 should be backup and 101 should be master. And now we are going to test by shutting down those ports. I'll go to switch 1. Interface range G00, comma G02. This is what I should have given. Now show IP SLA statistics.
Mm-hmm. 。 Give it some time. Give it some time.
It's taking this U-turn. Show VRRP. It didn't decrement it.
That's it.
Even though the interfaces are down.
No.
What can I do? Now, we need a layer 2 between this master and backup.
But if I put a router where
In
switch
the real
number
world, it
3,
won't go
put a
like
router
this,
there and put different
but
IP
in
address.
here, it goes like this. So because we got all 10 something, now what hell, why?
Okay.
Now I have to shut down this port and no, that one. No, that's not possible. For VRRP to work, you need these two active.
No, I'll shut down and switch
Otherwise, that
to
will become discontinuous. Both will
G00.
become master. To test this, I was doing something else in the previous class. I don't know what I did.
Okay. Yes, it's true. It's true.
Yeah, but I didn't record.
So did
Working
you do the same
very
video for the previous
nice.
class?
I don't know what I did. It was working
Oh, you
very
didn't record.
nice.
Oh man. Okay, I was saying.
This is trunk. Packet goes like this. I don't want to allow the routing. I want to allow the routing. Okay, I have an idea. I know what to do now. Wonderful. So I'm going to remove OSPF from G0/1. No IP OSPF. So no. So no. Remove OSPF from VLAN interface. Interface VLAN 2000. No IP OSPF 1. Area 0. Interface VLAN 2001. Same. And I'm going to put this on the other switcher. Do show history. Okay, this. On switch 2. Because it knows the route it is going. Now there is
No,
no
not
route, it won't go.
G01.
Now it becomes master, you see. 100, group 100, you see. It has become master here. Now it works because there is no route to reach now. If you try pinging now, you see it has become backup. If you try pinging 10.1.255.11, it won't ping. So that solves the problem. This is how I did in the previous class. Okay. Now, if you see show VRRP, this is the backup and this is also backup. You saw that, right? 2000 and 2001 or both are backup. And this is backup because the priority is being decremented by 5 from 100. The configured was 102. This is backup from early because the other one is 2102. The local one is only 100.
By 5.
Now,
yes.
if I bring show IP SLA statistics, you can see both are showing timeout.
Right. Show the statistics.
Okay. Now what is next is I'm going to bring the interface up to check whether switch one becomes master again.
Yes.
So interface range G0/0, comma G0/2. When I say this, IPSLA will come up again, OSPF will come up again, and the VRRP switchover will happen. OSPF has come, IPSLA has come, master. See, it has become master. Now let us go and test the other end. Right now, 102 is a master for 2001. Show VLAN.
Master.
Show VRRP. This is master here and the backup for 2000. And I'm going to shut down the ports so that the other switch will become master for both. Range G0/1-2. Yeah, so shut out. Now we are expecting this to go back up for 2001 because IPSLA will fail now.
Yes. Yeah, yes.
15 seconds. Yeah, down. So now it will move from master to backup. That's it. 2001, you see? We'll in 2001, group 101, master to backup. Show standby. Sorry, show VRRP. Both are backup. And the other one is master, switch 101.
Okay.
Master.
Yeah.
Let's bring this interface again.
Master, yes.
You got it, right? So master is back.
Yes, definitely. I got it. I got it. But send me the video.